Back today, we're looking at 4.3 complex numbers. Just to review from Algebra 2, complex numbers involve I, and then we know that I is the same thing as square root of -1. So, for example, if we're trying to solve x squared plus 9 equals 0, right? We can do this using our algebra. We can subtract 9 from both sides. And then we get x squared equals -9. And then if we're trying to get x by itself, we're going to undo the square with a square root. So not x squared. So x is equal to, now the problem with this is that the square root means that we're trying to find a number multiplied by itself that gives us the number inside of the square root. If it were square root of +9, that'd be easy. Then we know that it would be 3 and -3 because 3 times 3 is 9 and -3 times -3 is 9. But anytime we have a negative in our square root, then we come across a situation where we can't find something that multiplies by itself. We just said that -3 times itself is going to give us +9, so negative is not an option. Obviously, the +3 times +3 is not going to give us -9. So anytime we have a negative in the square root, what we can do here, well, let's just write it as we'd have it at that point. So we have positive negative square root of -9. So back in the day, scientists and mathematicians found that they were getting these negative square roots in their calculations for various things. So in order for it to be easier to work with, what they said was anytime we have a negative square root of 1, we're going to call that I. All right, so what we're going to do at this point is we're going to take our square root of 9 and take our square root of -1 and we separate them. So all we did was take this square root of -9 and we separated it into two separate multiplications. So we left the square root of 9 in one radical and then we took the -1 in another radical. And what that allows us to do is simplify this even further. So positive and negative square root of 9 is 3. And then we said that anytime we have square root of -1, we have I. So something you should have covered in Algebra 2, but if not, then just a quick review of it. So what this allows us to do is, because I is just a variable, it's easier to work with. It allowed the scientists and the mathematicians an easier time doing their calculations. All right, so let's kind of talk about what we can do with this stuff here. So what we're going to do here is we're going to find the zeros. So we're going to do it exactly like we did the last time. We're going to have to do some long division. I don't think there's any getting around it. But yeah, we'll talk about it when we get there. So we're looking at 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. So we're going to be finding that we're going to have i's in our calculations eventually, but we got to be able to get there first. So if you recall the last time, the first thing we did was we determined how many zeros possible we could have. So that was 4. Right, so the possible zeros, number of zeros is 4, because that's our highest degree. Okay, then we also said we want to find all the combination of zeros. Because we're doing the graphing, maybe not necessary for us to do it that way, but you can do it. But if not, then we can skip that step. So let me just write this down so we can go ahead and graph it. 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. Okay, so let's go back here. Whoops, sorry. Go to Desmos. I'm going to do 3x to the 4th plus 5x cubed plus 25x squared plus 45 minus 18. Oops, 45x. Okay, there we go. Let's take a look at this. So notice that we only have two zeros listed. So we have one at 0.333 and 0 and one at -2. So 0.0333 is the same thing as 1/3. And the other one is -2. So what we're gonna do here is we're gonna list the two zeros. So 1/3 and -2. So from the graph, we have -2 and positive 1/3. Okay, so unfortunately what we're gonna have to do here is long divide. And this is another thing that you guys did in Algebra 2, so hopefully this is a quick refresher. But let's change colors. So let's do, I don't know, let's do -2 first. It's a little bit easier. It'll help us get our feet wet and make the rest a little bit easier, hopefully. So 3x 4, 5x cubed, 25x squared, 45x minus 18. And actually, maybe we can show it long synthetic division for you guys, for those of you who have done synthetic division as well. So we'll do the first one long division, then we'll do the second part synthetic division, and then we'll wrap it up. So you're allowed to do whichever way you feel comfortable with. If you like synthetic division, then do it synthetic division the whole way. If you like long division, then you can do long division the whole way. All right, so the first thing that we need to do is we need to figure out what we're dividing by. So we're doing the -20 here. So actually it's x minus c when we're talking about our form for our thing. So -2 is the 0. So it's actually x plus 2 that we're dividing, because -2 plus 2 is 0. So be very careful on that first step, because if not, then we're not going to come out with 0 as a remainder, and we'd have messed it up already. All right, so make sure again that your factor x plus 2 is correct, and that the 0 makes your factor 0. -2 plus 2 is 0. Okay, so this is a quick refresher. We're keying in on this first term x, and then we're looking at our first term here, 3x to the 4th. So what we're trying to do is we're trying to figure out what times x equals 3x to the 4th. Okay, so that's going to be 3x cubed, right? So I'm going to treat these as individual columns like place values. So when I put my 3x cubed, I'm going to put it in my x cubed column with all the other x cubes. Okay, so step 1, we're looking at our x. What times x is equal to 3x to the 4th? Okay, and we said that was 3x cubed. Now what we're going to do with that 3x cubed is we're going to multiply it back into our x plus 2. So 3x cubed times x is 3x to the 4th. If we did that correctly, it should always come out equal to the thing above it. We're also going to do 3x cubed times 2. 3x cubed times 2 is 6x cubed. Positive. Okay, and then next step is we subtract. If we did it correct, again, these two terms here are going to subtract out. That's going to be 0. And then 5x cubed minus 6x cubed is negative x cubed. Let me clean up down here. It's bothering me. And we're going to repeat the process. So x again. What times x is negative? Oh, sorry. We're going to drop down the next term. And then we're looking at x. What times x is negative x cubed? That would be negative x squared. And then we multiply again into here. Negative x squared times x is negative x cubed. X squared times, negative x squared times 2 is negative 2x squared. Be very careful with your signs. And we're subtracting. Negative x cubed minus negative x cubed is 0. 25x squared minus negative 2x squared is positive 27x squared. one more time. This is getting a little bit tedious, I know. So we drop down our 45x. We're asking ourselves x times what is 27x squared. That's 27x. Then we're going to multiply it again. So 27x times x is 27. Whoops. 27x squared. 27x times 2 is 54x. Subtracting again. Add 0 like we expected. 45 minus 54 is negative 9x. Drop down the negative 18. And then one last time, thank goodness. What times x is negative 9x? That's negative 9. Negative 9 times, I'll multiply it here. Negative 9 times x is negative 9x. Negative 9 times 2 is negative 18. And then when we subtract, we should end up with the remainder of 0, right? Because it's a factor. Okay? So check. And the more important part here is that we got this more simplified version. So we already calculated out the factor of x plus 2, or the 0 from negative 2, right? So now we have a simpler version that we can do our 1/3 with. So let's do our 1/3 using synthetic division. So for synthetic division, what we're going to do is we're going to put 1/3 outside. And then we're going to write just the terms, the coefficients for each term. So then the first one is 3, right, for our x to the 4th. Then we have 5. Then we have 25. Oh, sorry. 3. I'm getting these all mixed up. So we're looking at this top one. So then we have 3. Then we have negative 1, right, because we don't have a number in front of our x. Then we have 27. And then we have negative 9. Okay, so for synthetic division, what we're going to do is we're going to drop down our first number. And we're going to multiply. Okay, so 1/3 times 3 is going to be 1. Then we're going to add the two numbers and drop it down. And we're going to multiply. We're going to add again. 27 plus 0 is 27. Then we're going to multiply 1/3 times 27, which is 9. And we're going to add again, and we should end up with 0. So this last one is going to be the remainder. And then this part would be the rest of it. And it goes in order. So this would be your constant. This one would be your x term, and then this would be your x squared term. So if we wrote this all out, it would be 3x squared. There's no x, and then there's plus 27. Okay, so this is important because this is going to help us find our complex zeros. Okay, so again, for our synthetic division, just to recap for those of us who like to do synthetic, because it is a little bit simpler. It's just so you have to remember what comes down and what multiplies and what adds. So the first step is we drop down the 3, right? And then we're multiplying. So we're always going to multiply our front number, right, which is our 0 from here, with the number on the bottom. So 1/3 times 3 is 1. And then once we do that, we always add the two numbers. So negative 1 plus 1 is 0. Okay, and then again, we're going to multiply 1/3 times 0. That's 0. And then when we add it again, we get 27. Then we take our 1/3 times 27. That's going to be 9. And when we add again, we should end up with 0 as our remainder. Okay, the 0 is the remainder. And then the rest of the things are our place values, kind of like what we did here. So It's easier to start at the end. 27 is the constant. The 0 for our x, so we didn't include it, right? 0x, there's no reason to include it. And then the last one, the 3x squared. Now, we found the 2 zeros, right? There's possibly 4 zeros, but in this case, 2 of them are going to be imaginary. So what we're going to do is we're going to set this equal to 0 and solve. So we're going to subtract 27. We're going to divide by 3. And this should kind of look familiar, right, from what we were doing the last time, because we end up with x squared equals -9. And then we square root. So x equals positive negative square root -9. And we said that if we break this down, right, we can just call that an I for the negative square root. So then x equals positive negative square root is 3i. Okay, so pretty complex, but I don't know. It's not too bad. There's 4 zeros. This is pretty complex math, but the skills involved in doing it are not too bad. For me, I think it's faster and neater to do it synthetic division. But if I ever forget how to do it because I know how to long divide, then I go back to long division, and I know that it's for sure going to work. I know one problem is that some of you guys didn't even learn long division in your elementary school, right? It's very rare that people learn long division in elementary school nowadays. So if you don't know how to long divide and you don't know how to synthetic divide, just default to the synthetic division because it is easier. Just that you got to be very careful and remember your steps. So I was going to end it here, but let's just do one more example because I think it'll be beneficial to all of us. So let's see here. Let's find a good one. Now let's do a shorter one because they're not all x to the 4th. I just did a long one just to check it out. But let's do this example. Where'd they go? Okay. Let's do x cubed plus 3x squared. So okay, let's do x cubed plus 13x squared plus 57x plus 85. X cubed plus 13x squared plus 57x plus 85. Okay, so for this one, the degree is 3, so we could have maximum of 3 zeros. Okay, so let's just go ahead and graph this. So x cubed, 13, 57, 85. X cubed, 13x squared, 57x plus 85. Okay. All right, so look here. Oh, it looks like we only have 1 0, and that 0 is at -5. Okay, so we'll work off that one. So we know when the real 0 is at -5. All right. Let's do this synthetic division. So for synthetic division, we put -5 outside because that's definitely one of our zeros. We found it on the graph. Then we're going to put our coefficients, right? So we're going to put 1 for our x cubed, 13 for our x squared, 57 for our x, and then 85 for our constant. And drop down our 1. And then we're always multiplying our front number with the things that come to the bottom. So -5 times 1 is -5. We're adding, right? So 13 plus -5 is going to be 8. We're going to bring our -5 times our 8 up here. And then 57 plus -40 is going to give us 17. And then -5 again times 17 is going to give us -85. And we end up with the remainder of 0, which is exactly what we want. Okay, so then for this part, we have, remember that's our x squared, our x, and our constant. So we have x squared plus 8x plus 17. Okay, so for this next part, this is a little bit harder to solve because it's not factorable and it's not one of those where we can just solve it algebraically. So what we're going to do is we're going to say, like we did last time, x squared plus 8x plus 17 equals 0. So what we're going to have to do, because we can't factor and because we can't solve it algebraically, is we're going to have to use the quadratic formula. So if you remember, x equals -b plus or minus square root of b squared minus 4ac over 2a. I'm just going to plug it in. So a is 1, right? B is 8 and c is 17. Okay, so let's put it all together. So -8 plus or minus 8 squared minus 4 times 1 times 17 over 2 times a is 1. I'm just going to simplify it, and whatever we come out with we'll be good with. So -8 plus or minus 8 squared is 64 minus 4 times 17, that's going to be 68, right? So let's write that down. 64 minus 68 over 2. Okay, we can do 64 minus 68 plus or minus square root of -4 over 2. So you can see where this is going to become imaginary, right? So we can change this -4 square root into square root of 4 is 2. And the negative square root inside the square root is going to be our I. And then because we can divide 8 and 2 by 2, let's do that. So we have -4. 8 divided by 2 is -4. And then 2 divided by 2 is 1i. And then we'd be done. All right, so our zeros, -4 plus our -1i. That's our two imaginary zeros because they have i's. And then our real zero, which is -5, which we found from the graph. All right. So, yeah, that's really the big picture for our polynomial functions. So you guys will probably be having a quiz coming up. Be ready for it. It's not going to be very long, I don't think. I'm just going to talk about all the things that we covered for the polynomial